Thanks, Lance, for doing this. Morning your time. This is a very exciting webinar. We had the most number of registrations for this webinar. Over 200 odd people have registered for the webinar. Unfortunately for all the faux pas with Zoom, it is what it is, but here we are. So very excited. So for all of you who are there, who are listening to this webinar and will join in the future, this webinar is a part of the series of Seed to Scale, Decoding AI. At Axel in India, we have started this series helping entrepreneurs, founders, AI engineers, and the AI enthusiasts discover artificial intelligence applications, and specifically very targeted around how to build applications in AI. And Langchain needs no introduction. I think anybody who has ever been interested in AI or has been building apps for the last 1 year or so has come across Langchain, and I think it's a go-to framework for people to build their AI apps. I am very excited to have Lance on the webinar. This webinar has taken 3 to 4 months in the making. First time I heard Lance was on the MLOps community. And it was quite exciting to hear him. I hope today's webinar is as exciting for all of you. He has agreed to do Langchain is so deep that I can't call it a masterclass. It's very difficult to cover everything in short, but he has agreed to give it a go. So here we are. Thank you, Lance, for doing this.
Absolutely. Well, it's great to be here. And actually, I spent a summer in India during college. I was very fond of my time there. In fact, Hyderabad as well as Kerala. So yeah, I always enjoy speaking with Indian community. It's fantastic. Can you see my screen?
Yes, we can see your screen.
Okay, maybe I should kick it off. So I'm Lance. I'm a software engineer at Langchain. I've been working with Langchain since March or February, but I've been at Langchain since about May. And I spent many years in applied AI. I actually worked on self-driving cars for many years, did a PhD at Stanford, and more recently have been obviously working very closely with language models, which has been a lot of fun. So maybe first just some context, what is Langchain? Langchain is really an application development framework that makes it easy to build LLM-powered applications. But it has a few different pieces. So at the bottom, we'll talk about this in detail, is some of the newer pieces we've introduced on platform. This is LangSmith, which is a set of tools for debugging, testing, and monitoring applications. In the middle here, you can see building blocks, and these are kind of the core pieces of our open source library, which people are probably more familiar with and have used. And at the top, I show kind of some common use cases, and we'll talk through all this. And I'll give you some kind of context as to how to use Langchain with these various applications. Let's talk about building blocks quickly first. So loaders, this connects kind of the Langchain world to your data or to different kinds of data. And we have a lot of them is the point. There's around 140 integrations. It covers both public data, like YouTube or Twitter, and proprietary data like your documents, your internal company documents, unstructured data, just like text files, as well as structured spreadsheets, APIs, and so forth. So this kind of gives you an overview of how to get data into Langchain. Now, text splitters are kind of the second piece here, and we actually have a playground. Text splitters are commonly used to basically break documents up and to put them and embed them in vector databases. So this is kind of a nice playground you can play with. We have many different text splitters. But beyond that, there's actually a few other things you can do with, we call document transformers as kind of the general category. We have a number of tools for what we call context-aware splitting. So you split the document, and it could be code, it could be Markdown, it could be PDF. But every chunk actually has kind of a tag as to where that came from in the original document. So it can be like, the abstract or the introduction within the original document, that's preserved in the chunks, which is useful context, which we can talk about a little bit later. We have other things like doctran that you can use for translation of documents. So I think the main point here is that you have loaders to pull data in. You have transformers like text splitters to break text up or to do other transformations on it. And then you have storage. So we have over 40 vector stores. We have over 30 embedding models. And this is very commonly used as an intermediate to store information prior to retrieval in various types of LLM applications. One interesting note here is that we have options for both hosted and private. So for example, with hosted, everyone's familiar with using OpenAI. For example, OpenAI embeddings are very popular, as well as hosted vector stores like Pinecone. But also if you want to do something only on your device, we have embeddings like Nomics, GPT for all that will run locally. We have vector stores like Chroma that of course will run locally as well. And for LLMs, we have over 60 integrations. And maybe I'll highlight some interesting tidbits of the LLM landscape. So everyone's probably familiar with OpenAI models, which vary in context window from 4K tokens up to 32K. GPT-4 currently is state of the art, kind of overall best performance. And the cost is around 0.06 cents per 1K token. But it's worth noting other models like Anthropic have emerged, a larger context window, very close to GPT-4 for Claude 2, 4 to 5x cheaper. And then the open source ecosystem with models like Llama 2 is becoming very popular. Smaller context window. The performance is on par with GPT-3.5. I show some details down here. You can see on language, it's pretty close. Here's 3.5, here's Llama 2. This is Llama 2 7dB. But it does lag quite a bit on coding, which is an interesting to talk about. We might talk about that a little bit later. And of course, they're free. Now, one other cool thing about these models is, actually, I'll go in slideshow mode here. Sorry, I realized that that might help a little bit. They run locally. So this is Llama 2, for example, running at 50 tokens per second on a Mac M2, 32 gigs. So that's kind of the benefit. Open source models, of course, are smaller, a little bit less performant, but they're free. They can run on device. And so they're very interesting to kind of track in terms of the progress. We have this integrations hub, which gives you kind of a nice overview of all the various integrations we have in Langchain. You can see kind of on the left here, over 140, well, 140 exactly loaders, over 40 vector stores, embedding models, and so forth. You can kind of browse here. I'll share these slides, of course, and the links, but you can kind of browse and see what integrations you're interested in and what you want to test. Now let's talk about use cases. So this is kind of a nice overview of all the different building blocks, but like, what do you want to use them for? What can they be used for in kind of practical applications? Probably the most popular, which a lot of people are interested in, is RAG, retrieval augmented generation. And the idea here is, we all know these large language models are trained on large corpus of data, typically like large amount of internet data as well as code. But of course, it doesn't mean it does not include your data. It doesn't include your personal documents, doesn't include your company documents. That's proprietary. So a very popular paradigm here is to simply take documents that are relevant to a question from a local storage, i.e. a vector store, and load those into the context window of the model. And then the model kind of has this information available to it to answer the question. This is like a very general concept. So we talked about loaders, we talked about splitters, we talked about storage. We introduced this new idea of a retriever system, often a vector store, which, given a question, you fetch relevant splits using some methodology. Could be similarity search or otherwise. And you load that into the prompt, and we'll actually show exactly how that works here in a minute. It's worth noting that Langchain has a few different ways to do this, a few different levels of abstraction. So if you want kind of a pipeline that will just work, you pass in the loader, it does everything else. We have vector store index creator. If you want to specify the splitter, the vector store independently, retrieval QA. If you just want a chain to handle like kind of prompt and LLM, load QA chain. So it's important to recognize about Langchain, you can use it at many different levels of abstraction. And this is just kind of one example of that. Now, this is where I want to walk through this a little bit slowly, because this is introducing one of our new tools called Langsmith. So Langsmith is very easy to use. You set some environment variables, and every time you use Langchain, all your generations are logged to a dashboard, and you can go and explore everything you did later. And in particular, you can see, here's one example of retrieval chain I ran. You can see here's the trace. So here's exactly what's going on, right? So I ran retrieval QA on some vector store with some question. And we can see here's where we actually retrieve some documents. And this is actually the LLM call, and this is actually the prompt. So this is showing you, this is the system message, totally fine. Use the following pieces of context to answer the question. If you don't know, just say you don't know. And this is literally the chunks that we retrieve from our system pertaining to the question. Here's the question. LLM processes, this is exactly what the LLM sees. LLM produces the response. So this is, the Langsmith trace is actually linked here. You can explore that, but this gives you kind of a nice window into what exactly is going on under the hood when you're running these chains. And when you're running LLMs, it's often kind of confusing to know, well, what exactly was the prompt that was passed in? And this is one way to see it. And with retrieval, you can see really all you're doing is you're grabbing documents from your vector store of similar system using some kind of search, like similarity search, based on your question. So maybe even unpacking that a little bit more, you take your question, you're embedding the question, you have all your documents, they're also embedded. You do some embedding lookup for similarity. You fish out documents similar to your question. And that's what you see right here. These are those documents. Pass them the model processes them and produces the response. Now, one extension of this is chat. And really, chat is kind of just augmenting what we just talked about with the idea of memory. So it can remember the whole history of your conversation. And of course, you can have chat plus retrieval. Those two can work together where you can inject documents into your chat flow. So this is just a trace for chat. You can see all that's happening is you're persisting the history of the conversation over time, and you pass it into the context of the LLM. It has this whole history when it's producing responses. That's all that's going on. There's different types of memory. I linked to the documents here. You can kind of explore. There's different types of buffers. Some will preserve just a summary of the conversation to save tokens. Others will pass the full conversation verbatim to the model. So there's some interesting options to consider. Summarization is another big use case, and we can kind of walk through this one a little bit slowly. We have some interesting, very specific examples as well here. So the idea here is you want to take a document and summarize it. And often it's not just one document. It often is like a large corpus of documents. So the kind of key decisions are, does it fit into the LLM context window? If yes, you can just pass the documents in exactly to the prompt and tell the LLM to summarize it. If no, you have some options. You can basically cluster the embeddings associated with the documents. You can break the document up, cluster them, and sample from clusters. So here, all you're saying is, hey, these chunks of the document are similar, pick one per cluster. Take those samples, pass them into LLM. That's it. You can also take each cluster and summarize it with an LLM call as well. So that's like, imagine all these similar documents that are read, just pass them all to an LLM, say, what's happening in this cluster? LLM answers you. And the third option is this idea of MapReduce, where you take every chunk of your corpus and you summarize each chunk with an LLM. You pass those summaries to a second LLM to say, distill the summaries into a final summary. That's this MapReduce idea. So we've actually used this, and we have a repo here. Obviously, we'll share the slides. We've tested clustering and MapReduce on a very, typical application. Langchain gets thousands of questions about our documents every day. And we actually use these summarization chains to summarize. What are people asking about? What are people confused about? And we actually did this with Mendable, which is one of our partners. They handle all the QA in our documents. And you can see this is like a breakdown of the various question categories using different methods. They're pretty consistent, which is a good sign. This is using different models. We use Anthropic. We use different methods, MapReduce and clustering. We use, yeah, again, you can see the different models here. And the nice thing is I share the blog post below. I share the notebook. You can look through all that's all open source. But what's nice is you can, with Langchain, you can very easily use different models to do this kind of summarization. And it's very easy to plug and play. You can try Claude 2, you can try GPT-4, GPT-3, 5, 16K. It's easy to plug and play. So this is kind of one very practical case where we use summarization to benefit our documentation. Another use case is extraction. So this is a classic problem. LLMs output raw text. If anyone's ever tried to take that raw text output and stuff it into something downstream, an API call, say you have like some kind of database, you want structured data, it's very tedious. You have to do lots of prompt engineering to get the model to produce JSON, for example. And functions really open this up. It's very helpful and important to look at. So here's a good example. You have some input string. Tell the LLM the schema of what you want. I want, these objects with properties, name, height, hair color. And you describe the function call you want the model to execute. The LLM will actually take your input, execute the function, produce output in the schema you specify. Very, very helpful. And here we can see exactly what's going on under the hood. There's a Langchain trace. So we can see the prompt is telling them extract and save relevant entities mentioned in the following text. Use this information extraction function to do that. Here's the passage. And what you don't see is we've passed this function in with this schema to the OpenAI API. So OpenAI has the knowledge of this function. It has the knowledge of the schema we want out. And the prompt just says, hey, use this function to process the output. Here's the passage. And there you go. You get the output as desired. Now, what's kind of nice is this chain also runs a parser, takes this JSON, parses it for you, and you get exactly just this object out. Very nice. So that's how function calling kind of works with extraction. It's very, very useful. So I highly encourage you to check out. We have a lot of documentation on that here as well. But this is highly useful. And maybe I'll talk about one or two more. We can just get into free-form questions then. Texas SQL. A lot of people kind of intuitively know what they want to access from SQL databases in natural language. Writing SQL queries is tedious. I think many of us, particularly software engineers, don't necessarily love writing SQL queries. LLMs are very good at doing that. So we have a number of different chains that allow you to take a natural language question, map it to a SQL query SQL database, and we also have LLMs that will kind of process that answer for you. Here's what's going on. Again, let's look under the hood a little bit. There's some interesting papers that have shown Texas SQL is quite effective if you pass the LLM a create table description for the tables in your database with some examples in a select statement. So if you give the LLM this context, it's able to write SQL queries. It's very interesting. So this is exactly what's going on here. And you can see that given a question, it's able to kind of produce valid SQL, given context about how the table is structured. So LLM is very, very effective at doing this. And I mentioned that agents can be used here. So this may be an interesting segue to like kind of what agents are and why they can be useful. One simple way to think about agents are things or objects that have access to tools and have access to memory. So we can kind of walk through it. Like a basic LLM has no tools, no memory. Now, LLMs with function calling can have access to tools, but not necessarily memory. So like we've just shown that you can have function calls that will access, you can have LLMs that will run function calls like API call. That's kind of the tool. You also have chat chains which have memory, like we talked about previously. Now agents kind of combine these two ideas. It's basically these objects that have both memory and tool use together. And we'll walk through exactly how this works with SQL. Now, just to give you a quick overview, agents are a big topic. Langchain is a pretty big agent ecosystem, but let's kind of walk through the key pieces. We talked about tools. So there's lots of tools and toolkits available in Langchain you can give to agents. Search, access to email, access to data frames, various APIs. So that's like the tool part of it. Then there's memory. We talked about chat, short-term memory, that's available. Also, longer-term memory is available, like vector storage. We also talked about that with retrieval. And then there's like the question of planning. How do agents actually plan? And there's a bunch of different flavors. So you've probably seen some of the more popular, like autonomous agents, like AutoGPT, Baby AGI. These are like long running agents that have different mechanisms for long-term planning of tasks. There's simulation agents. The generative agents paper is very interesting. And there's also what we call action agents, which are agents that just decide kind of very myopically the next action to take. And React was kind of one of the more famous frameworks for action agents and became very popular. And maybe I'll give you a little bit of flavor on React. So really all that's happening here is we talked about standard prompting. Now, chain of thought was an extension to standard prompting, which tells the LLM to really show its work or think step by step. And this conditions the LLM to work more slowly. You do less computation per token. It tends to produce better results. It encourages the LLM to kind of more carefully walk through a chain of logic. There also is notion of tool use. So things like SayCan, this was some robotics paper. This is a robotics paper out of Google. Kind of showed how you can use tool use to produce action observation pairs. So a tool, LLM has a tool, acts on the world, gets observation back, acts, observation. React was to say, hey, let's combine these two. We have an LLM, it has a tool, it can perform an action, it gets an observation, but then it reflects on it, it thinks, and so it uses this kind of chain of thought or multi-step reasoning. That's the main idea behind React. That's really all that's going on. And let's actually see how this works in practice. Here's a SQL agent. Now you can see the trace here. This is all the steps it's taking, which is helpful. I mean, I think agents have been a very confusing area because it's hard to actually teach what's under the hood, but this really shows you what's going on. So we're kind of midway through the trace here. And basically the input is list the total sales per country, which country's customers spent the most. And the action was, you can see here, list the tables. There it is, there's the observation. So again, tool use action, observation, here's all the tables. It used this tool here, got the tables. Now I'm thinking. It's using some chain of thought reasoning. And here's the generation from that thinking step. I should query the schema from the invoice and customer tables. And this is the action it takes. You can see as you go down the flow, it then applies the tool to take this action, if that makes sense. So again, it's prior action, get the observation for the action, get the tables, think about it. Okay, I have these table names. Now I want to get the schema for these tables, and then it'll apply that tool, and then it'll just go down the chain like that. And this is how it comes up with the answer. This is exactly, that's all that's going on. It's nothing crazy. But I think agents have been a very confusing topic. So anyway, I want to get to Q&A, so I won't take this too much longer, but this gives you like a deep kind of insight, hopefully, into kind of how React agents actually work. One thing I'll note, agents aren't the most reliable, and people have probably seen this from their own work. We recently been working on web retrieval. We started this in agent. We actually found a retriever was better for this particular task. So I think this is just a caveat that you don't always need to use an agent. For this particular task, basically we want a system to automate web research. We thought about an agent. So you imagine you can ask a question, agent can go do a web query, get the result, look at the result, make a decision, query again. Instead, all we do is take a question, use an LLM to break it up into a number of sub questions or related questions, query them all in parallel, bunch of HTML pages, load them all, store it in a vector store, do similarity search, basically works really well. Don't need an agent. So anyway, that's just a thing to highlight. And yeah, this is it's all open source, repos here. This is kind of showing it in action. It's a fun little tool, but again, start with an agent, eventually didn't end up using one. So it's good to be realistic about what agents can and can't do particularly effectively. And the final thing I'll note, I know we want to get to questions, so I don't want to take too much of your time on just me blabbering on, but basically, I highlighted this a few times, but Langsmith is quite useful as a tooling, debugging, and observability kind of framework. So here's an example of how you can use it in practice. You have an app, you're collecting feedback, and you have the way to collect bad feedback, like when the model's doing wrong things, right? Imagine you have some way of doing that. You can collect all those in Langsmith pretty easily. You can filter on kind of good versus bad. And for everything that's bad, you can inspect it, like what's going on actually, look at the trace. But even more interesting, you can look at the input and output of that chain, and you can actually correct it. So you can say, here's the output that the model gave, and it's wrong in some particular way, and I can fix it. So you can actually edit it within Langsmith, produce the correct, kind of create your own ground truth, save that to a data set. Okay. And so kind of the overall flow then is that you can be collecting app feedback, collect bad feedback, put in an eval set, fix your app, and then you have this eval set in Langsmith. We have a bunch of evaluators already in Langsmith. Once you fixed your app, you can rerun on that same eval set you've already collected and grade yourself again. That's it. Very simple, kind of very obvious eval flow. But the point is, tools like this for LLMs have been a little bit lacking. Obviously, there's a lot of new tools coming out now, but Langsmith is one of them, and it integrates very nicely with Langchain, of course. It's a very nice place to kind of look at your generations and spec, like we showed throughout this whole talk, and also to produce evaluation sets and reevaluate your models. So that's it. And again, this would show, you fix your app, regrade it, redeploy, collect more feedback, new eval set, fix, reevaluate, and so forth. And go around the circle. Hopefully your app gets better over time. I think that's all I had. I think we have plenty of time for questions, and probably better just to do it more interactive anyway. So yeah, I mean, I'm happy to go through anything else, but also happy to just take it to questions. And thanks for your time, and very nice to talk to you all, you guys.
Thank you for that, Lance. Maybe you can stop sharing and we can start taking all the questions which people have posted in their Q&A. Sure. I think Langsmith looks to be very powerful. Obviously, the most popular question is going to be, how do we get access to Langsmith since it's in closed beta right now? So
yeah, I can address that. Yeah, so actually, everyone, I believe, as of now, has been removed from the waitlist. So actually, if you sign up, you should get access. And we have some, I can share some access codes if there are further problems. But from talking to folks on our side, I believe everyone has been removed from the waitlist. You should be able to get on immediately now.
Awesome. And if anybody has problem, we might bug you.
Yeah. No problem.
Attendees on this webinar, hopefully we'll get everybody access to Langsmith who wants. So I'll just go in serial order as to a bunch of questions which have been posted here. So Vilanki is asking, and you can look them up on your end on the Q&A side as well.
Yeah, I see it.
Yeah. So the first one is, are there was a way of leveraging Langchain agents for linking multiple LLMs plus trigger automated workflows to do forecasting, clustering, or network optimization? Is there a way? I think the question is there a way for Langchain agents to link multiple LLMs?
Yep. Yes, it should be possible to do that. I will share I'll find a way to share this with the community. I will share some agent demos that utilize multiple LLMs. I don't think we have any cookbooks out of the box, but actually I've been working on refactoring all of our docs right now. So I will include some examples of that. we can go to the agent piece. Typically with agents, so maybe just to give a little bit of context, agents can be used with many different LLMs within Langchain. So that's kind of the first point, which is good. One thing we've observed is that LLMs that have poor coding capacity, this goes back to the llama stuff, tend to do worse as agents. And it may be because agents require kind of very structured reasoning. It's a little bit unclear, but for example, we've seen Llama 2 agents perform worse than GPT-3.5 or 4 agents. So that's something that's kind of a caveat. But I think the point is that they were curious about whether or not you can use agents with multiple LLMs, and you can do that. And whether or not you can actually chain agents together, you can also do that. So, for example, look at Baby AGI. There's a Langchain implementation of that, and it has a number of different agents which interact with one another. And each of those agents could be instantiated with a different LLM. So I think that hopefully answers the question. You can certainly use different LLMs with Langchain agents, and you can certainly interact, kind of connect them together. Look at Baby AGI as a good example of how to do that.
Actually, Lance, interestingly, like as an investor, one of the questions I have is, are agents ready for full prime time use, like to be put in front of customers or not? Like,
yeah, my sense is it's a good point. To be honest, in many cases, no. There are some very interesting companies that are pushing state-of-the-art agents, Multion being one, Divgar's company. So there obviously are, I think, there's a small set of companies at the state-of-the-art agents that are probably quite close to production. But for example, the agents you'll just see in open source libraries, including Langchain, it's not entirely clear that anyone is using these in production right now. There's still some experimental things like AutoGPT, Baby AGI, certainly experimental, all promising. But I would look at the small set of companies that have really hard production agents like Multion. My sense is they are reasonably close for narrow use cases.
Thanks for that. Next question is from Ashwin. He asks, is there any way to increase the context length of input tokens above maximum without using any stop?
That's a good point. So that's typically a limitation of the LLM. So we kind of talk through different LLMs and different context lengths. So of course you can opt for different models, like Anthropic gives you very long context length. 100K tokens is like 75 pages of text. That's a lot. Now, if you still hit these limits, then I would suggest doing things that we talk about in summarization, like the MapReduce chain. So again, think about what's happening here. You're taking some massive set of documents, you break them up into chunks. Each chunk, you send that to the LLM, do something on that chunk. That's the map step, summarize it or something else. And then you have all these mapped summaries, you then further reduce them into a final summary. So this is a way of getting around context limitation models. You can do this on very, very arbitrarily large sets of documents, depending on your budget. But that's the point. If you really hit a context window limitation, you can always do this kind of MapReduce style flow where you kind of break documents up and process them one by one. Or to be honest, smarter is probably something like clustering. Embed your documents, cluster them, and only pass kind of unique sampled subsets to the LLM for whatever you want to do. Otherwise, you're wasting tokens on things that are very, very similar. So that's what I would say about that.
Actually, the next question is very connected to text splitters. And the question is, text splitters are very inefficient and they have a lot of overlap window. So the trivial context is missing many times because of the splitting, right? So how do you, I think it's the same question as context windows.
Oh, I see, right. Yeah, exactly. Okay. So, it is true that text splitting is kind of frustrating. It would be nice to be able to skip that entire stage and just be able to pass context directly into LLMs. I think my answer there would be, well, certainly there are larger context LLMs coming out. 100K tokens for Claude 2 is pretty good. That's 75 pages again. 32K for, I believe there's GPT-4 32K, definitely 3.5 32K. Again, pretty good. So that's happening on the LM side. One limitation is the open source models are still quite small context. So that's a real limitation for that. Text splitting, embedding, storage is probably going to remain really the preferred way of doing it. And by the way, even if you have a 100K context model, if you're working with enterprise data, which is massive, you still can never fit all of it into context. So you need some kind of strategy to split and store embedded chunks for retrieval in a lot of practical and enterprise settings. So I don't really see any way to get around that to a degree, although context windows are definitely getting bigger. Yeah.
Next question is from Udayan. He asked, does conversation buffer memory used in chat application cases uses contextual compression?
Yeah, that's a good one. So actually, the use case doc covers this. It can. There's an option to specify that. Where is it? So this use case documentation, I'll share the slides, of course, you can see, but we do use contextual compression in some of the chains. I can find the chain name here. If you can, well, I maybe don't need to do this right now, but basically, I'll find it right now. Check out conversation summary memory will keep a summary of the conversation to save tokens. That is a very useful trick, and I would recommend it. Yeah.
Yep, I think.
Oh, and this is similar. Using Langchain, summarizing and storing the responses. Do we lose the context? Okay, this is a good point. There's a trade-off always. So if you use summarization memory or contextual compression, you will lose some granular details of the conversation. It's a trade-off. So if you have a very, very long conversation, you don't have the tokens. Back to the prior question about context length. If you don't have the context window to support a very, very long conversation, you need to do some kind of compression, but you will lose detail. So there's kind of no free lunch. One option could be keep the whole conversation history and use a very large context model like Claude 2 100K tokens, or you are just, there's a few other options. There's also options to keep the last K interactions in the conversation. We also show that in the docs. So that's like, if you just want to keep a buffer of the last like 10 interactions, that's a way you have all the detail, but you of course will still save tokens because you're not passing the entire history. That's another option.
Yep. Let's go to I want to pick up one of the more interesting ones. Maybe the SQL. There's a question on SQL and LLM models.
Yeah, sure.
So the question is text to SQL and LLMs. My own experience is that LLMs cannot convert questions to SQL when the questions get from simple to intermediate. So,
right.
More complicated SQL, how does that work?
Right. Well, okay, this is a good point. One, I think you do hit up against just a limitation of the LLM at some point. There's no question about that. I would obviously consider using state-of-the-art model like GPT-4, for example, to get the best quality text to SQL conversion or give you the best chance for complex queries. But it is true that there's going to be limitations. One workaround to this is consider the SQL agent. Now, agents open up another can of worms, I agree. So I'm not saying agents are kind of the default go-to in a situation like this, but agents have some benefits. They can do kind of restart, so they can try multiple times. They can reformulate queries. They can sometimes attempt to break down the question into multiple parts and query each component. Also check the use case documentation. There's some tricks you can use for basically trying to check the queries for accuracy or for compatibility. So basically, I think there's really no great solution to this. If you have very complex questions, it is definitely possible to hit the limitations of the LLM's capacity. In those cases, maybe try an agent that can kind of retry it multiple times. Maybe just break your question down into simpler pieces. Frankly, I'd be curious to see some of those examples. So maybe there's a way you can get in touch with me Actually, my Twitter is linked. So I would actually be curious to see that.
Awesome.
Yeah.
One more simpler question: is Langchain supporting tree of thought as well?
That's a good point. It is supported, but I don't cover it in the documentation, but I should. I will make a note to add that actually, because I'm overhauling all our docs right now. I do think that'd be very interesting to include. So the answer is yes, but I should add it to our use case documentation. I'll think about the right place to do that. I'll make a note of that right now. Yeah, that's a good point.
Great. Okay. Yeah, I'm just trying to choose a good question.
Sure.
Is there some use case of Langchain where we can mask confidential data while training an LLM so that other? Oh, I think this is more of a LLM question rather than a Langchain question. But is there?
This is actually a good point, though. I will share. Okay, I'll share an interesting blog post from a company called Glean that does a lot of work on enterprise search. They talk a lot about where is it? I'm finding. So this retrieval augmented generation flow, Glean for enterprise search has this problem. It's like, hey, I have all these users, they're searching documents, and how do I ensure that security permissions are honored? And that's more of a retrieval architecture question than an LM question. And actually, this blog post from Glean, I'll insert it here so that when I share the slides, you'll see it. It's very interesting because it talks a lot about this is really what enterprise search solutions will focus on. So it's a little bit more of like a retrieval architecture question than an LM question. It'd be something like in this retrieval system, it has some awareness of the user, it knows user permissions, and like it will retrieve documents per those permissions. It's more of that kind of thing.
Yep. Awesome. One question on agents. So how do callbacks get applied in custom chains or agents, which we construct for our own use case? Does it take into account all completion and prompt tokens that goes in the process?
Yeah, it should. And I will, when I share agent documentation update later this week, I will include that specific example of how to do that. You note that I don't share the agent docs because they're not quite ready yet, but I'll make a note. Where's that question? I'm going to make sure I add that.
This is the first question.
Top one. Yeah, how do I see it? I'm going to add that right here.
Thank you for doing this.
Yeah, it's good. Well, I'm updating all our docs now anyway, so actually it's good timing.
Right. Okay, I'll just say we answered this live. Yeah, the next one, I think people are throwing in a lot of questions. It's great. I think, but I don't want this to become a very support kind of webinar.
Yeah. Well, it's actually helpful to get all the questions because we're updating our docs, so it's good.
I think this question is a more simplistic question. Somebody's creating a conversational agent for business stakeholders, and they need multiple databases, LLMs, ML models. I think Langchain already does this. And they're trying to use this for query resolution.
To be honest, I would say that taking a query, decomposing it into subparts, querying different databases depending on different parts is actually non-trivial. Well, it's obviously non-trivial. So we're actually working on some good documentation now on query decomposition. I still think, to be honest with you, that in a business setting, an enterprise setting, realistically, you will probably want a real enterprise solution, something like Glean, that has been doing this for a very long period of time. It is non-trivial. And we will definitely be sharing some documentation on query decomposition very soon. I'm going to make a note of that. But in an enterprise setting, I actually think you probably want a very hard enterprise product for retrieval. Glean being one, for example. If you have a use case where you have to very, very reliably interact across a large number of different data stores and combine that information, that is like a hard enterprise retrieval problem. Yeah, so we got that one.
Yeah, next one is interesting. This is like streaming data support in Langchain.
Yeah, there's lots of support for streaming. We show that in a lot of places. Yeah, like, so for example, in this little web app we showed, this is obviously streaming. Have a look at the code here. It shows some nice demos as to how to set up streaming. You can set it many different ways by providing an LLM a callback that works with many different LLMs. So streaming.
No, I think this is more around, it seems like this question is for e-commerce data, where there's a lot of live streaming transaction data coming in. And is there any vector database that you might know of which supports high volume input data?
Okay, that's interesting. Yeah. So for that, I'm going to make a note of that as well. You should check out integrations page. There's 40 vector stores, and there's certainly at least a few that can handle, streaming data without a question.
Interesting. I didn't know that. Okay.
Yeah, this brings up an interesting point, though. Data freshness in retrieval applications is very tricky. So, for example, if you have a vector DB, how often are you re-indexing all your data and like updating that database? And so, actually, I'm going to make a note of this. This is good motivation for something that we are putting out somewhat soon. So I'm going to make a kind of a question. There's a few different things here. So one is we have a blog post yesterday with Airbyte, which is one interesting option for data connection, which handles a lot of this kind of like data versioning, like what's in your vector DB and what's in your like kind of your, say you have a buffer that's capturing your stream, keeping those in sync is a tricky thing. So Airbyte's one option for that. We also have some new tooling on our end coming out to support that. So I would check out tools like Airbyte that handle ETL and what support is there for streaming, new Langchain tool coming out soon, any existing vector DBs. I mean, streaming is always going to be tricky with vector DBs, right? You're going to have to buffer them, embed those chunks, and load them up. So yeah, I think realistically, you're going to have some latency. You're going to have some kind of like ETL schedule that you need to maintain with streaming data. It's a great application, though. I'm actually, I'll dig into this a little bit more as well on my end. But I would first start with like looking at things like Airbyte integration, which came out yesterday. Look at new tooling we're putting out soon, and check out all existing vector DB integrations to see if streaming supported with some of them.
Yeah, I'll take one generic question, which is very interesting. One is, have you seen any very, very interesting vertical use cases in the industry where Langchain has been applied? And along with it, there's another question, which is Langchain makes it so easy that it's like leveling the playing field for most startups. So how do startups build any moat around what is already, like, how do they build their moat given Langchain?
Yeah. No, that's a good point. That's a good point. So the first one on applications actually kind of maps for use cases. RAG is a huge application. There's a very good talk actually from Frank Slootman of Snowflake and Jensen Huang of NVIDIA. I can share the link. It was at their latest summit where Jensen Huang, they're partnering, and the question was why. And Jensen says, every piece of data will become an application. You can build LLMs, kind of make every piece of data interactive. All your customer data, all your organizational data, your documentation, all becomes interactive. And so there's a large surface area for applications there. A lot of that's going to be enabled by something like a RAG style pipeline. With, for example, what one of the prior questions mentioned, high quality retrieval tooling will certainly be very important there. So RAG is a major kind of enterprise use case that we're certainly seeing quite a lot of. We've actually been focused a little bit more on some of the platform layer on observability and tooling, which is kind of central across all the different use cases. And we're seeing a lot of interest in this to support things like RAG. Summarization is another big one that we see a lot of. Chat is another big one. So I would say RAG, chat, summarization are significant enterprise applications. Obviously, extraction is kind of a piece of the puzzle there in a lot of RAG applications. SQL, to be honest, I think it's certainly a very useful dev tool. I don't know if it's like a major enterprise application at this point quite yet, but it may be in the future. Agents, not yet. Agents are coming, but not yet. That's kind of my sense of the landscape. With respect to competition, I think this has been true of ML for a long time. It's always about your data. That was actually true in self-driving as well. Self-driving was a very tightly guarded space of ML models for many years, but frankly, the models over time commoditized, the data was differentiating. And that's true here too. So if you're a company, it's really your data that's your differentiated advantage. It's not the models. In fact, what's cool about this whole industry is it's flipping self-driving and other parts of ML were always highly differentiated models. This is kind of flipping that everyone has the best model. And it's all about what data you have because everyone has the same model effectively. So it's entirely different, which is exciting. And yeah, it does level the playing field, but also opens up the surface area for applications hugely.
Yep. I want to pick up the question which is right in the end, which is more around hallucinations. So the question is from Aditya. He's talking about they're doing something with medical data, patient data, and creating examinations for doctors. And how do they make sure they're trying to use vector embedded RAG, but they want to make sure that there are no hallucinations. So should they fine tune the model, or is there what is a better way? What is a better approach to improve accuracy and have less?
Yeah, okay. This is interesting. Yeah. I'm just reading the question again a little bit to be careful. Yeah. Okay. So let's go back to retrieval QA chain. So one of the common things to reduce hallucinations is the notion of retrieval. Because really what you're telling the model to do is use only this context to answer the question. If you don't know the answer, just say you don't know, and you're giving it the context itself. So retrieval is one tool. This is quite effective. Obviously with temperature 0, this is already pretty good. Now, when you get into a safety critical setting like health, I think that's probably where you start to think about overlays. There's a package from Shreya called Guardrails AI, which is interesting. I think you kind of get into the world of legitimate LLM safety and need for additional checks on top of the LLM, like guardrails or otherwise. So that's probably what I would say there. I think at the LLM level, things like retrieval, low temperature, obviously help a lot with hallucinations. But then on the output side, you probably need additional things like guardrails.
Yeah. Thank you for that. Folks, we are coming towards the end of the webinar. And, just in the interest of time, I just wanted to thank Lance for doing this. Sorry, we probably could not pick up all the questions. But I also want to plug in about our own AI accelerator. So Axel in India has launched the AI accelerator where we are investing in AI startups. And, would be great if you folks here are interested to apply for it. The applications are open. We'll be starting off the batch on the first week on 20th September. That's the high level. And a lot of you have asked questions on whether the slides and the recording will be available or not. We'll be making the recording available in the next few weeks on our website and YouTube channels. And Lance has gracefully said he will share his slides as well. So really, really thankful for that. And Lance, really, really thankful for taking out your time. I know, Langchain must be very busy at Langchain. You're a small team with a very active project. So, thanks for that. Thanks for doing this for us. So,
yeah, definitely. There's a lot of fun, great questions. Feel free to DM me on LinkedIn or on Twitter to follow up. And I made some notes here to address the questions that came up that we didn't have immediate documentation answers to. So,
all right, thank you.
Yeah, find me online.
Thank you, Lance. Thanks for doing this. Hopefully, we'll see you more often, and hopefully, we'll get you to India as well one more time.
Very nice, of course. Thank you very much. Okay, bye.
Bye.